Welcome back, Physics 11. This is the second video for the week. I know, right? Crazy amount of video for 1 week. I just wanted to give you some help solving 4 problems. These problems are similar to the quiz problems that you're going to get. So if you understand these, you should be able to understand the questions that are on the Google form for the homework this week. I wanted to start out with a few tips. And if you think about these tips, I'm going to hopefully go through all 4 of these in some order when we go through these 4 practice problems. So one thing is you will need to at some point, or with these problems, switch between looking at the total circuit, that is looking at V total, I total, and R total for the whole circuit, or individual components, like looking at one component and saying, what's the voltage across this, what's the current across this one component, and what's the resistance across this one component. So you have to switch back and forth. And so if you're stuck, again, this is a way you can try looking at big picture or try looking at individual component. A lot of times you're going to need to redraw the circuit to simplify it. So if I have a circuit that looks like this, so I got one resistor here, one resistor here. Well, if this is 2 and this is 3, we know that the total resistance in the circuit is 5 ohms. So this would act the exact same way as if we had one resistor that was 5 ohms. So sometimes it's easier to redraw the circuit. And again, that ties into this idea here of like looking at the total resistance, total voltage, total current. The other one is don't forget to use Kirchhoff's law. So if you're stuck, is there a loop somewhere that you can look at? If you're stuck, is there a junction somewhere you can look at where you know this current is going to equal this current plus this current? Or if you have a circuit that has multiple loops, then maybe you just want to look at one loop at a time. Maybe I just want to look at this loop that goes here, or maybe I just want to look at this loop that goes here to see what I want to solve. Maybe that one bit of information I can solve. And so remember, the loop law is that the voltage up is going to be the voltage down. So whatever, if you go up by 9 across the battery, you're going to go down by 9 across this. Another way of looking at it, though, that's very helpful for the loop law is that each branch has the same potential difference. So if this you find out is 9 volts, then you know that this is also going to be 9 volts. So it's another way of looking at it. And if you're really feeling stuck, then just start seeing what you can solve. So look at the various components in the circuit and ask yourself, hey, do I know the voltage drop across this particular resistor? Do I know the current through this particular resistor? Do I know the resistance of this particular resistor? And if you know any 2 of those, then you can immediately solve the third. So looking at individual components and thinking, for that component, do I know either V or I or R? If I know 2 of those, I can solve for the third one here. So let's work through these problems together. I would strongly encourage you to pause the video between these questions and try them out for yourself. But here goes. Anyways, I'm just going to run through them and again encourage you to pause to try them out yourselves. So here we go. What are the values of I1, I2, and I3 in the circuit below? Well, this is one of those ones where I would encourage you to refresh it or redraw it as one single circuit. So in this case here, I know that I1, I2, and I3 are going to be the same everywhere. So that's really nice. That tells me that I1 equals I2 equals I3. That's great. That's a great place to start. And so if I know the current through any one of these, I know the current through the whole circuit. Well, let's just redraw this here. So here I've got a 12-volt battery, and I've got a 3, a 4, and a 2 ohm resistor. Now for resistors, I know for series, R total equals R1 plus R2 plus R3. And so in this case here, 3 plus 4 plus 2 is 9. So essentially this is the same as a circuit that's got a 12-volt battery and a 9 ohm resistor. And I know V equals I times R. Therefore, I equals V over R equals 12 over 9 equals 1.3 amps. So there's my answer for the first one here. All right, hopefully that makes sense. This is going to, yeah, 4/3, 1.33. Okay, good. Let's look at number 2. What's the value of R2? So, tricky one here. Well, there's a couple of ways of solving it. One of them is, well, one thing that we're going to have to do is use one of Kirchhoff's laws. So here's one thing I know about this loop here. So I'm going to do Kirchhoff's law for loop number 1. I'm going to draw the loop this way. I'm going to call this L1, and then L2 is going to be this loop, and L3, so this is L2, and L3 is going to be this loop here. This is L3. So for Kirchhoff's loop law, it tells me that the voltage across any loop equals 0. Now this cell gives it 24 volts, so that means if we're looking at loop 1, that the voltage across here is going to be 24 volts. And that's also going to be the same here. So let's just zoom in and we can annotate our diagram here. So V1 equals 24 volts, V2 equals 24 volts, V3 equals 24 volts. Now what about the current? So we know V equals IR, so I equals V over R. So this I is going to be I equals V over R. Let's move this over here a little bit. I equals V over R. This is going to equal 24 divided by 40. And whatever that is, let's see, 24 divided by 40. Let me get my calculator here. This is going to be 0.6. So the current here, I1 equals 0.6 amps. Okay, so that's an important bit of information we have here. We have 0.6 amps. I'm going to do the same thing over here for I3. I3 is 24 divided by 60, and 24 over 60 is going to be 0.4. Okay, so here's what I've got so far. I have got all the voltages and all the voltages of all three. I've got the currents of this one here, this resistor, and I've got the current through this resistor. And there's a total of 0.6 and 0.4. Now, over here, we see that the total amount of current is 1.8. And so this 1.8 that's going through this way, 1.8, well, 0.6 of it goes down this way, 0.4 goes down this way. So how much is going through this one here? Well, let's use Kirchhoff's junction law. Kirchhoff's junction law says that the current going into a junction here is equal to the current coming out of the junction. So here we've got 1.8 going in, we've got 0.6, 0.4, and so there must be 0.8 remaining to get a total of 1.8. So now, here's what I know for the second resistor. I know I2 equals 0.8 amps. And so if I want to find the resistance, R equals V over I. You can, I know this is kind of old school, but you can do this triangle here. So if you want to know what the R is, you just cover up the R with your finger, and then you'll see that the equation is V over I is going to be V divided by R, and V is going to be I times R. Okay, so in this case here, I is V over R, which is going to be 24 divided by 0.8, and so R2 equals V2 over I2 equals 24 divided by 0.8, and 24 divided by 0.8 gives us 30. So that's going to be 30 ohms. One other way of solving this would be using our resistance formula for parallel resistors. This would be a little bit trickier, but you could do it in one step instead of a bunch. So in this case here, we know R total equals V total divided by I total. This is the idea of going to the whole circuit. Now this is going to be equal to 24 divided by 1.8. So what's 24 divided by 1.8? That gives us 13.3 ohms. So this is the total resistance here, 13.3 ohms. And we also know 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over 13.3 repeating equals 1 over 40 plus 1 over R2 plus 1 over 60. Again, this might be more complex mathematically, but you would still end up, if you solve through this, you would still end up with R2 equals 30 ohms. So it could be solved using tip number 1, which is look at the big picture versus the individual components, or it could be solved kind of with that step number 4, look across each component and ask yourself those questions. Do I know V, I, and R for each component? If you do, then you can solve it that way. Okay, what is the potential difference? Number 3, what's the potential difference supplied by the power source, in this case that's the battery here, for the circuit? This is one of those ones where you are going to want to solve for the total. You're going to need to basically redraw this circuit. So in this case here, I'm going to redraw this circuit as follows. So I got an ammeter, and this is still going to be 2 amps. This is going to go through this, and then I'm going to change this thing here into one single resistor. So if I change that into one single resistor, it's going to look like this, and the total resistance of this whole thing, total resistance of this can be solved using 1 over T equals 12 plus 1 over 24. And so let's get the calculator out here. 12 inverse plus 24 inverse equals 0.125. So 0.125. That's going to equal 1 over RT. And so RT is going to equal 1 over 0.125. So I'm just going to take the inverse of this, and that gives me my total resistance, which is 8. So this whole thing has a resistance of 8 ohms, and this is also 8 ohms. So this is 8 and 8. If I want to redraw this, now it looks like this. So there's my ammeter, and there's one resistor. And if we have two 8 ohm resistors in series, they just add together. So this is 16 ohms. So now, this is what I know for my circuit. I'm trying to find V total. V total is going to be I total times R total. So this Ohm's law is true for entire circuits just as much as it's true for individual components. So in this case here, the I total is 2 amps and the resistance is 16 ohms. And so this is going to be a 32 volt power supply. Okay, that is number 3. And last but not least, what are the values of V1, V2, and R2? So we're trying to find V1 meaning this, V2 meaning this, and R2, we're trying to find this right here. So it seems like there's not a huge amount of information, is there? Well, let's figure out what we know. So this is one of those scenarios where I think it might be better to start thinking about the individual components. Now, there's only one component here that we know 2 quantities for, and that is this one right here. So let's use red for voltage here. So V we know is I times R. So instead of looking at the whole package, we're just going to look at one individual component, and for this individual component, I know the current going through it. So the current going through it is 0.30 amps. I know the resistance is 20 ohms, and I know V is equal to I times R. So V for 4 is equal to I through 4 times the resistance of 4. So 0.3 times 20 is 6. So this is going to be 6 volts. So V4 is 6 volts. Now, what else do you know? Well, we know this is, again, it's kind of an interpretation of Kirchhoff's law. Kirchhoff's law tells us that the voltage in any loop adds up to 0. But another way of interpreting that is that the voltage in each branch is the same. So if this is 6 volts, if it loses 6 volts going down this path here, remember what we're saying is this coulomb of charge, 1 coulomb of charge, goes through here, and it's going to lose 6 joules of energy if it goes up the right path. Well, guess what that means? That also means it's going to lose 6 joules of energy if it goes up this left path. The voltage has to be the same. The amount of energy it loses has to be the same whether it takes the right path or the left path. So now I know a little bit of extra information here. I know V3 is also equal to the same, which is 6 volts. And so what does that tell me about the current? Well, I equals V divided by R, and so this is going to equal 6 divided by 30, and 6 divided by 30 is 0.2. So this part here, I wish I had purple ink. I should really get purple ink here. Okay, so purple ink for I3 equals V3 over R3 equals 6 over 30 equals 0.2 amps. Okay, so now I know this bit of information here. I know that I3 is 0.2 amps. I know I4 is 0.3 amps. So what is the total current through here going to be? Well, we know Kirchhoff's junction law. So if it's 3 going this way and 0.2 going this way, that means it's going to be 0.5 amps. So 0.5 amps is going through this circuit here. Now, when it gets to this part where it splits, it is going to split, so 0.3 goes to the right, 0.2 goes to the left, but overall, there's still 0.5 amps for the circuit. So V total equals 60 volts for the circuit. I total equals 0.5 amps. And so R total is going to equal, well, again, we're looking at the total circuit here. R is V over I, so 60 divided by 0.5 is 120 ohms. So I got this new bit of information here as well. The total current, and so this is all kind of in its own little area here. This is the total circuit information. V total is 60 volts, that's what's given by the battery. I total is 0.5, that's what's going through the circuit. And R total then by calculation has to be 120 ohms. So let's try and see what we can figure out here. Let's try and solve V1. Well, V1 is going to equal the voltage across here. Now, do I know I for this component here? So I know R through this component, I'm trying to solve V through this component. Do I know I through this component? Yes, I do. I is going to be, and again, I is the same through here and here and here. I is going to be 0.5 amps. And V equals I times R, so 0.5 times 18 equals 9 volts. So this is going to be 9 volts here. And we also saw that this here was 6 volts. So it might be worthwhile, if you have the option to do this if you want to redraw this circuit. So I'm going to redraw it this way, where I've got 18, an unknown value, and then this new resistor here. And so this resistor here, if I want to know the total resistance of two things in parallel, well, I know 1 over RT equals 1 over R3 plus 1 over R4. And I'm going to call this R34 because I'm combining resistor 3 and resistor 4 into 1. So this is going to be 1 over 30 plus 1 over 20, and then take the inverse of that. So I'm just going to put it all in brackets. So 30 inverse plus 20 inverse, inverse, and then take the inverse of that. And that gives me this total value. So R34 equals, let's see. Okay, so this is, sorry, I got distracted there. This is 18 ohms. This, as we just said, was 12 ohms. And this one here, R2, this is still a question mark. However, we do know one extra bit of information, and that is that the R total, the whole circuit, is going to be 120 ohms. Remember, we figured that out here when we looked at the whole circuit. The total voltage is 60, the total current is 0.5. V divided by I is R, so that's going to be 120 ohms. And this is equal to the sum of the three resistors. So this is equal to 18 plus 12 plus R2. And so we can quickly see here, this is the same as saying 120 minus 30 equals R2, which is just equal to 90 ohms. So the answer to R2 is 90 ohms. So we know one final answer there was R2. V1 we said was going to be 9 volts. We already solved that one there. We've solved R2. And V2 is just going to be the difference in voltage. So one thing we can do is we can look at this individual component and say that V2 is I2 times R2. So that's 90 times 0.5 which is going to be 45 volts. Or we can also realize, so that's one way of doing it to solve it for 45 volts. Another way of doing that is just to say we know the total voltage is equal to 60, and this is equal to, in a series circuit, V1 plus V2 plus V3. V1 we saw was 9 volts, is equal to 9, plus V2 plus V3, the voltage here was 6 volts, and so V2 equals 45. So 60 minus 9 minus 6 is 45, 45 is V2. So they both give us the same answer. So one thing that you're going to find with these problems in general is there is definitely more than one way to solve almost all these problems, which makes them enjoyable. I really hope that you try them out and think of them like a puzzle. Think of them as just something fun to do. Hopefully you find them as enjoyable as I always did when I was taking physics in high school. And if you have any questions, which I'm sure many of you will, hopefully I will see you in the live stream. All right. Thanks very much.